Okay, so we're going to talk about a p-value. Now, back in exercise 13, let's see. Let's look at exercise 13. It's over here. The study of older students in exercise 3, so now we got to go look at number 3, so you can stop the video and reread these if you need to. Anyway, here's question number 3, and it talks about the attitude of students. Now, the average attitude is about 115. Now, the teacher thinks that older students have a better attitude about their studies. Now, what happens is they take a look at these older students, and their score is much better, 125, versus the average, which should be about 115. Okay, now the p-value for this sample is 0.01. Okay, what does that mean? That's what we're talking about right here. Now here's the deal. Your HO, right, your null hypothesis is either true or it's false. That's it. Okay, so it's either 100% true or 100% false. One or the other. You can't have a 1%. Now, but what does this 1% mean? What it means is there's only if it's true, okay? If it's true that the average is 115, right? The fact that we got 125.7 would only happen 1% of the time. So we just got extremely lucky, if this is actually true, to get a score that high. Okay, so that's what it means. We have it's basically, that would only happen 1% of the time to get a sample this big for these students if it was true that the true average was 115. Okay, that's what that means. Let's go to the next one. Okay, here's number 19, and you have to read this thing about response times for emergency personnel. So basically, the average response time is, here it is 6.7 minutes, like that. So, and then the city manager shares the information and encourages them to do better. And then at the end of the year, takes 400 calls and checks out whether they did better or not. So, what we're going to do is we're going to say, well, letter A. What are the hypotheses for the significance test to determine whether the average response time has decreased? Be sure to define the parameter of interest. So, we're going to say that the null hypothesis is for letter A. The null hypothesis, HO, is going to be that the average response time, so we're using mu there, mu, is 6.7. And then we're going to say that the alternative response time is going to be that it's less than 6.7. Okay, there's our two hypotheses. Null hypothesis and alternative hypothesis. So let me draw a picture. It just always helps me to draw a picture of what this looks like. So we're going to say that our average response time is 6.7. Now they don't talk about an alpha level, but let's just say we have something over here. Now what we're going to say is, well, let's talk about a type 1. A type 1 error. What does that mean? So at the end of the year, there's either no change, remember I say that a lot, right? No change after the year, or they did get better. Now let's just say that we take a sample, what is it, there's 400 calls or whatever, and we get a sample that's really low. The average is pretty low, well down here. So type 1 error is we reject the null hypothesis in favor of the alternative hypothesis, even though there was no change. So we made a mistake. We think that they're getting better. Okay, there's that. And then the type 2, that's when we get a sample and we take the average, and it's in this area, kind of close to 6.7, and we just assume that they really haven't gotten better, even though they have gotten better. That's a mistake. That's a type 2 error. Fail to reject the null hypothesis, even though they got better. That's a type 2 error. Okay, those are the two. Now we have to decide which type of error is more harmful, type 1 or type 2. Okay, I think it's type 1, because type 1 is saying, yeah, we got a lot better, we're doing good, even though they haven't improved. That would mean that they would stop making changes to make the response time better, and more people would probably die. So that would be a problem. Type 2 error, that's not really a problem at all, because type 2 error is saying they did get a lot better, even though we think they didn't, so they're going to try even harder. Now that might stress out the personnel, but they're going to work harder to get there faster. That's what we want. Okay, so type 2 error, not great, but type 1 error, that's going to present many more problems for people. Okay, there's that. Also, one more thing, I just want to point out that right here, it says page 538. I always say this, there's a problem just like this on page 538. It's really important that you look in the chapter and follow along with those examples. The examples are really good. Sometimes you have to read them more than one time, or read them, get a little bit out of them, come to class, think about it, come back and read it again. I do it all the time. I still read those examples before I come to class to try to share this stuff with you. Okay, so